Hi there. In this video, we talk about linear correlation, what it means and how to measure it. And in the subsequent video after this one, which you will watch, we will talk about how to create a mathematical model for points that are correlated linearly, or for data that's linearly correlated. But first of all, we're going to talk about linear correlation. Now, linear correlation means that you are measuring the degree of relationship between two variables. In chapter 3 or earlier on, you may have learned about bivariate data. So here we're talking about bivariate data. That's data that has two variables. What is the relationship between those variables? Is there a linear relationship there? That's what linear correlation measures. For example, you may want to think about the number of hours you study and your grade on an exam. We may be able to see that those are correlated, in a linear fashion. Or the number of sick days an employee takes, or employees in a company take per year, and the age of the employee, right? Are those correlated? That may be something an employer may be interested in. Or the number of years of schooling and the level of income a sample of in the population earn, right? Is there some relationship there? Or the number of calories consumed at breakfast on a certain day and the distance traveled that day, right? Is there a correlation there? And now, whenever you are talking about correlation between two variables, you may want to think about which one of the variables is independent or dependent. Usually, the variable you want to predict is the dependent one. So, for example, with the number of hours of study and grade on an exam, you may want to you would want to predict your grade on the exam, given the number of hours you study. So, the number of hours you study then becomes your independent variable, represented by X, and the grade on an exam becomes the dependent variable. You will represent that by Y, and you will see some of that following. So, for example, if you are thinking about the number of hours you study and the grade on an exam, so you will have a bunch of hours of study and grade, and you can plot this in what you call a scatter plot, like this. You can see that on the x-axis here, I have the hours of study, and on the vertical axis, you have the marks earned, the grade. And you can see that the more you go to the right, it seems the points are getting higher and higher. So, for example, if you read that graph, the very first point on the bottom left represents a person who studied only 1 hour for the exam. Look at their mark. They earn like 10%, right? And then there's somebody who studied for 3 hours. Their mark is 35%, and so on. Okay, so this is a scatter plot. And what this means, when the points are rising, the more you go to the right, you say that this data set, these two variable data set, they are positively correlated. There's a positive correlation between the two variables, number of hours of study and the grade on an exam. Or the number of sick days the employees in the company take against the age of the employees. Look at this one. You can see this one, that the points seem to be falling the older the employee gets, right? That one has an inverse relationship, you will say, right? You will see that a person who is a person who is 17 or just about 15 years of age, right? You can see how many sick days they take. They take almost 15 days, right? 14 days there. As opposed to a person who is older, like the 55-year-old guy, he only takes about 3 days, right? So that's falling. You would say that these variables are negatively correlated. So there's a negative correlation between these two variables here. Or the number of calories you consume at breakfast and the distance traveled that day. Those points might look like this, right? Because I don't think necessarily there will be correlation between those two variables. Maybe there will be. It depends on the sample you take, but I'm just illustrating here. Those points may look like this. So when the points are clustered around like that, They are not, you can't really tell whether they're rising or falling as you move along the x-axis. You say there is no correlation there between those two variables. So what we are going to do next now is to talk about how to measure correlation. We're going to put a number on it. We measure correlation using what we call the Pearson product moment correlation coefficient. We represent this with the variable little r, like that. And r is this number will range from -1 to 1. Okay, so it can be -1 or negative 0.5 or 0 and so on, all the way to 1. You cannot have a correlation coefficient of 2, for example, or -5. You can't have that. It has to range between -1 and 1. Sometimes you have a correlation coefficient of -1. Now, it's not always that you have this or usual, but sometimes you have this. If your correlation coefficient is -1, you say you have perfect negative correlation. But usually, instead of having a perfect negative correlation, what you have most of the time is a correlation that is close to -1, but not quite -1. Maybe like -0.75, -0.8, -0.92, things like that. Then you say that the correlation is strong and negative, okay, correlation. Or you could have a perfect positive correlation, in which case R is equal to 1. Now again, usually you don't have this. What you have is something that is strong and positive correlation. The value will range around 0.8, 0.85, 0.9, 0.97, right? It will be close to 1, but not quite 1. You say the correlation is strong and positive in that case. Sometimes you have correlation of 0, okay? Like in the previous scatter plot I showed you with the number of calories or amount of calories consumed at breakfast and distance traveled from home, right? There may be no correlation there, in which case R will be 0. Again, sometimes, usually that may not happen, but you may have a correlation that is weak. So it will range maybe around 0.3, negative 0.3 to maybe positive 0.3, something like that, around 0. You say there's a weak correlation. And then everything else, you can have positive, moderate correlation or negative moderate correlation in there, just like I've shown you here. Okay, so to calculate R, then, here is the formula for R. Now, don't be afraid. You've seen formulas like this before. It's not very difficult. You can see the sigma. The sigma is simply saying that you are summing together x and y, x multiplied by y, minus, you are summing x multiplied by sum of y divided by n, and so on. That is what this formula is. So we're going to use this to look at an example. So here's the example we're looking at. We want to calculate R for this data set. So this data set represents, on the x-axis, you have the years of schooling, and on the y, you have the income in thousands of dollars. So a person who went to school for 7 years, only barely completing grade 7, is earning about $25,000 a year. And a person who had 2 years of schooling, maybe they're not educated, maybe they're earning 19,000 or maybe less, who knows, and so on. A person who went to school for 16 years, that's a person who had college, university, they're earning almost 70,000. Okay, so that's what we're thinking about here. If you put these points on a scatter plot on the x and y axis, you will have this scatter plot that we have here. You can see on the y-axis the income, and on the x-axis you have the years of schooling. You can see that the points seem to have a positive correlation, right? The more you go to the right, the higher the points seem to get, okay, on a general level. So let's confirm this hunch, or what we think would happen, by calculating R. So to calculate R, from our formula, we need the sum of x and y, so we're giving those. Here we have x and y, we're going to add them later on. And then from our formula here, we need x squared and y squared, because you can see in the denominator you have summation of x squared and summation of y squared. Okay, we need summation of x and y as well. We'll do that a little bit later. So if you do x squared, take all the x's and square them, That's what you will get. If you take all the y's and you square them, right, you will get those as well. And if you sum them, those are the sums. Summation of x, summation of y, summation of x squared, summation of y squared. And here is your xy and the summation. So all we do then is take those sums and plot them in our formula like so. Summation of xy is 2,585, so that goes in there. Then minus summation of x times summation of y divided by n. N is 6. 6 means that the total number of data points that you have, there are 6 of them for each variable. So if you substitute all this in the formula and you calculate, your result will be 0.844, right? So to 2 decimal places, 0.84. So that's a strong positive correlation, is what this is, right? So R equals to 0.84 means that there's a strong positive correlation between the number of years of schooling and the annual income of the people in that sample, the 6 of them. So this is how to calculate R. So now you try. You try and determine the value of the correlation coefficient R for this data. The data represents the number of hours of study versus the grade, okay, earned on the exam. So what I want you to do now is you should go ahead and pause this video right now while you try this example. And when you have finished, you can continue the video to see what I have done. So please pause the video now. Alright, so what did you do? Here is what I did. So here are the hours and the grade. You have all the variables you need, x squared, y squared, and xy. So if you calculate those and you put those in, I hope this is what you have. If you sum all the x's, you have summation of x. If you sum all the y's, you have summation of y, and so on. And then those go in the formula. Our formula is as shown. If you substitute in there, you will get the following, right? And then you calculate R, you get 0.89, right? I hope that's what you have, which implies that there's a strong positive correlation or a strong positive relationship, linear relationship between the number of hours of study and the grade earned on an exam. And if you want to plot the points on the x and y axis, right? There, look at that, right? So you can see the hours of study and the grades, and you can see the points, right? The more you go to the right, the higher they seem to be getting on the y-axis. So that confirms that we actually, right, there's a strong correlation here. Okay, so we have come to the end of this video. In our next video, I will show you how to create a linear model. Okay, once there is linear correlation, how do you create a linear model for this? I will show you that in our next video.